Beneath the Amazon's vast green canopy lies a secret. This colossal rainforest isn't just watered by rain, it actively conjures it into existence. It's a living, breathing engine, a planetary marvel. How does Earth's greatest forest literally generate its own weather, defying nature's rules to sustain itself? The Amazon rainforest operates on a remarkable internal hydrological cycle, distinctly different from regions primarily relying on oceanic evaporation for their rainfall. This vast ecosystem isn't merely a passive recipient of moisture. It actively creates and recycles a substantial portion of its own precipitation. Scientific studies indicate that a significant percentage of the Amazon's rain originates directly within the basin itself, rather than solely from distant ocean sources. This extraordinary self-watering phenomenon is powered by intricate mechanisms, setting the stage for what scientists call flying rivers, immense atmospheric currents of moisture that transport water vapor across the continent. These airborne rivers ensure continuous rainfall for vast areas, underpinning the forest's unique ability to sustain its own lush, vibrant environment. The magic begins with transpiration, the forest's mighty respiratory engine. Billions of Amazonian trees act like giant pumps, drawing incredible amounts of water from the soil through their extensive root systems. This water then travels up to their leaves, where it's released as invisible vapor into the atmosphere through tiny pores called stomata. This isn't a small-scale operation. The sheer volume of water transpired daily is staggering, equivalent to an inland ocean evaporating every single day. The tree's remarkable ability to access deep groundwater, even during the less rainy spells, ensures this continuous, monumental release of moisture, making transpiration a pivotal first step in the Amazon's self-watering cycle. Following the immense exhalation of moisture by billions of trees, the Amazon's atmosphere becomes a localized, super-humid environment, perfectly poised for the next stage of its self-watering journey. Here, the forest plays another ingenious role. It releases biogenic volatile organic compounds, BVOCs. These naturally emitted organic molecules don't just add to the air's unique scent, they are critical. Acting as essential cloud condensation nuclei, these tiny particles provide the necessary microscopic surfaces for the vast amounts of water vapor to cling to and condense around, initiating the birth of cloud droplets. This abundance of vapor, combined with these natural seeds and the specific thermal updrafts generated by the warm forest canopy, rapidly facilitates the formation of dense, rain-bearing clouds. The Amazon's unique atmospheric chemistry thus efficiently converts transpired moisture back into life-giving precipitation, completing a vital step in its remarkable internal water cycle. The remarkable journey of this internally generated moisture continues through atmospheric currents, often called flying rivers. Prevailing winds like the Atlantic trade winds pick up the vast quantities of water vapor released by the western Amazon's forests. As these airborne rivers of moisture travel eastward across the immense basin, they encounter a significant natural barrier, the towering Andes Mountains. Instead of crossing, the moisture-laden air is dramatically redirected southward. This redirection is crucial as it funnels vital rainfall to vast regions of Central and Southern South America, extending the Amazon's hydrological influence far beyond its immediate borders. This entire process forms a continuous, self-sustaining loop. Rain falls, is absorbed by trees, transpired back into the atmosphere, forms clouds, and then precipitates again, sometimes hundreds or even thousands of kilometers from its origin, perpetually watering the continent. However, this marvelously self-regulating system, so crucial for its own existence, faces immense threats. Deforestation and destructive land use changes are its greatest adversaries. When vast tracts of forest are cleared, the very engine of transpiration significantly diminishes. This means fewer flying rivers of moisture are generated and less biogenic volatile organic compounds, BVOCs, are released to act as vital cloud condensation nuclei. The direct consequence is significantly reduced rainfall within the basin. This triggers a dangerous feedback loop. Less rain fosters drier conditions, making the remaining forest acutely susceptible to devastating fires. These fires further degrade the ecosystem, accelerating deforestation and decreasing rainfall even more. Scientists warn of critical tipping points, where the Amazon could irreversibly transition from a lush rainforest to a drier, savanna-like landscape, carrying catastrophic global climate implications for everyone. The Amazon's self-generated rainfall, a marvel of nature, highlights its critical and fragile role in global climate. In your opinion, how can understanding this system help us combat desertification elsewhere? Share your thoughts in the comments.